Hello, so in today's class we'll move on to the next topic. So that is on expansion of functions. So here we'll be seeing what is called a Maclaurin series, and we'll see what is called Taylor series of a given function. Now, provided your function is differentiable infinitely many times, so we can express it as a series involving powers of x അല്ലെങ്കിൽ so you can expand it as a series which involves the powers of x, which contains the terms x, x square, x cube, so on, or you can expand it as a series which is containing the powers of x minus a. So if it can be expanded as a series which is involving powers of x, so such a series is called a Maclaurin series. And if you have a point A, so A is not equal to 0, so if the given function can be expanded as a series which is in powers of x minus a, so such an expansion is called the Taylor series expansion of a function. So, in today's class, we will look at what is a Maclaurin series and how to find the Maclaurin series for a given function. So, let us find out what is the Maclaurin series. So, let f of x be a function of x, and let f be expanded in ascending powers of x. And let the expansion, so the expansion is infinitely differentiable. So let the expansion be differentiable term by term. That means in the expansion you can differentiate every term, so any number of times. And so here given the function f of x, now we are expanding the function in the ascending powers of x. So f നെ നമ്മൾ x ന്റെ പവേഴ്സിൽ represent ചെയ്യാണ്. So let f of x be equal to, so if such an expansion is possible, then f of x will be equal to a0 plus a1x plus a2 x square, then a3x cube plus a4 x raised to 4 plus etc. would come. And now we have said that the expansion is differentiable term by term any number of times. So f dash of x is obtained by differentiating each term exactly once. So we'll get a1, then 2a2 x square, then 3a3 x square, then 4a4 x cube plus etc. So when you take the second derivative, that will be 2a2 plus you will get, okay, let me write it as 3 into 2, this is a3 x plus 4 into 3 a4 x square plus etc. Now similarly when you write the third derivative, that will be, so the derivative 2a2 is 0, so we will get 3 into 2 a3, then 4 into 3 into 2 a4 x cube x plus etc. So when I substitute now x equal to 0, so in the first equation x equal to 0 substitute here, So from the second term onwards, that is going to be equal to 0. So put x equal to 0 in the above equations. So from the first equation, we will get a naught equal to f of 0 varum. From the second equation, a1 will be equal to f dash of 0, and in the third equation, 2a2 will be equal to f double dash of 0, and from third equation you will get 3 into 2 a3 equal to f3 of 0, then you will get 4 into 3 into 2 a4 equal to f4 of 0. So we can write a naught as f of 0. So a1 can be written as, so I can write it as f dash of 0 by 1 factorial, and a2 can be written as f double dash of 0 by 2 in 2 factorial, and a3 will be, now 3 into 2 into 1 is 3 factorial. So this can be written as f3 of 0 by 3 factorial. Similarly, a4 will be f4 of 0 by 4 factorial. So therefore f of x will be equal to, so instead of a naught you will have f of 0, then a1 will be f dash of 0 by 1 factorial into x, and f double dash of 0 by 2 factorial x square, f3 of 0 x cube by 3 factorial, and the nth term is going to be, the general term is fn of 0 by n factorial into x raised to n plus etc. So this series is called as the Maclaurin series, and this result is called known as the Maclaurin's theorem. So this is how we obtain the expansion of function in powers of x. So let us see a few examples on the expansion. Okay, so let us first look for the common functions. So first one, expand the following functions by Maclaurin series. The first one, if you have f of x equal to e raised to x, then we know that all the derivatives of e raised to x are going to be itself. So in general, fn at x will be equal to e raised to x. So therefore, fn at 0 will be e raised to 0 is 1. So therefore, the Maclaurin series of e raised to x is, so e raised to x will be equal to, so f at 0 is 1, and f dash of 0 by 1 factorial into x, then f double dash of 0 is again 1 by 2 factorial x square plus 1 by 3 factorial x cube plus x. So that is summation n equal to 0 to infinity x bar n by n factorial. So that is the series corresponding to e raised to x. So if you have f of x equal to cos x, let us look at the expansion. So when you have cos x, so f dash of x is going to be equal to minus sin x, and f double dash of x is minus cos x square, and f3 of x, the third derivative is sin x, and the fourth derivative is equal to again cos x. അപ്പോൾ ഫോർത്ത് ഡെറിവേറ്റീവിന് നമ്മുടെ ഒറിജിനൽ ഫംഗ്ഷൻ വരും. ഇനി ബാക്കി നമ്മൾ ഡെറിവേറ്റീവ്സ് എടുക്കുമ്പോൾ ഇതേ സാധനമായിരിക്കും നമുക്ക് റിപ്പീറ്റ് ചെയ്യാം. ഓക്കെ, സോ when you take f at 0 will be 1, f dash of 0 will be 0, f double dash of 0 is minus 1, f3 of 0 is 0, and f4 of 0 is going to be equal to 1, and this will continue. So therefore Maclaurin series, so cos x will be equal to, so f at 0 plus f dash of 0 by 1 factorial x, f double dash of 0 by 2 factorial x square plus etc. So the first term will be 1, second term will be 0, third term will be minus 1 by 2 factorial x square, and third term is 0, fourth term is f4 വരുമ്പോൾ plus 1 വരും. So x raised to 4 by 4 factorial. So it is going to continue in this pattern. Okay. For 1 minus x square by 2 factorial വരും plus x raised to 4 by 4 factorial. അടുത്തത് even powers ആയിരിക്കും വരിക. Minus x raised to 6 by 6 factorial, then plus x raised to 8 by 8 factorial minus etc. So this can be written as summation n equal to 0 to infinity. So this is x raised to 2n by 2n factorial minus 1 all raised to n. So when n is 0, x raised to 0 is 1, 2n factorial is 1, 0 factorial is 1 ആണ്. So 1, then minus 1 raised to 0 is 1. So first term will be 1. When n is 1, negative sign varum. X square by 2 factorial. 2 varumbo plus sign varum. X raised to 4 by 4 factorial. So this is the required series for cos x. Expansion of x equal to log 1 plus x. So here okay, f at 0 will be log 1 is 0. So f dash of x is 1 by 1 plus x. So therefore, let us find f double dash of x. So that is minus 1 by 1 plus x whole square. Then the third derivative will be 2 by 1 plus x whole cube. Fourth derivative is minus 6 by 1 plus x whole raised to 4. Okay, so it is in the standard form. Okay, then 0 factorial 1 plus x down. So this is minus 1 factorial 1 plus x whole square. This is 2 factorial 1 plus x whole cube, and this is minus 3 factorial 1 plus x whole raised to 4. So in general, f1 at x will be, so first let us write the factorial. n minus 1 factorial ആയിരിക്കും വരുന്നത്, and 1 plus x whole raised to n വരും. And when you take okay 0 നെ ഫസ്റ്റ് ഡെറിവേറ്റീവിന് ഫംഗ്ഷൻ വാല്യൂവിന് നമുക്ക് ജനറൽ ഫോമിൽ എഴുതാൻ പറ്റില്ല. From here onwards you can write in a general form. So 1 വരുമ്പം സൈൻ പോസിറ്റീവ് ആണ്, അതായത് ഓഡ് വരുമ്പം സൈൻ പോസിറ്റീവ് ആണ്, ഈവൻ വരുമ്പം സൈൻ നെഗറ്റീവ്. So this will be minus 1 raised to n minus 1, or minus, you can write minus 1 raised to n plus 1. So that is the general form of the nth derivative. And now let us look at the value of derivatives at 0. So f of 0 is 0. So f dash